Okay, so we're going to talk about division of decimals, where the divisor is a decimal. And this is section 1.5 in your textbooks. So if you look on page 20 of the text, you'll see this passage. So if you want to read it together with me, all of the division problems you have solved so far have had whole numbers as the divisors. When the divisor is not a whole number, it has to be multiplied by 10, 100, 1,000, or some higher power of 10 to create a whole number. Both the divisor and the dividend have to be multiplied by the same number so that the value of the quotient is not affected. This can be done by moving the decimal points of the dividend and divisor an equal number of spaces to the right. So we're just going to start pulling out what this text means. So when it says, when the divisor is not a whole number, it has to be multiplied by 10, 100, or 1,000, or some higher power to create a whole number. Let's look at exactly what this means mathematically. Because we know we'll be moving the decimal, but we want to know why this works as well. So let's think. If we were going to multiply 32 hundredths by 10, we would do 0 times 2 is 0 times 3 is 0. Then we'd go to our next row. Because it's the second number, 1 is our second number, we need a placeholder. And then 1 times 2 is 2. 1 times 3 is 3. And when we add those, we have 0, 2, and 3. And we're going to use our rules of multiplication. So we go out 2 and back 2. So if you see with this, we multiply by 10, so we see the decimal point moving, but it doesn't move quite far enough. So we want to make 0.32 into a whole number, we'll try 100. So multiply 0.32 by 100. Like before, we have our first row of all zeros. We have a placeholder, and 2 more rows, another row of zeros. The 1, we need 2 placeholders. And then 1 times 2 is 2. 1 times 3 is 3. We add these up. We have 3, 2, 0, 0. And we use the rule of multiplication. Move the decimal point 2 out. Then our answer, I have to move it back 2. So this is how it works mathematically to create this decimal movement. So that's what it's talking about when it says you're multiplying by some power of 10. And then now we're going to look at the second part of that. Both the divisor and the dividend have to be multiplied by the same number so that the value of the quotient is not affected. So we're just going to look at why this works. So we're going to look at 1 divided by 10. So we're going to think of that as a fraction. So this is 1 whole, and we've divided it into 10 separate segments. And this is the 1/10. So we're going to show why it's equal if you do both multiplications. So we're going to multiply 1 by 10 and 10 by 10. So then we end up with 10 divided by 100. So if you compare that to our graph over here, we see that this is a 10 by 10 grid. So that means that there are 100 blocks in this. And if we fill in 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is still equivalent to our original division problem of 1 divided by 10. So this is why it works. We have to apply it to both the divisor and the dividend to keep this equality. So now let's see this in action. So our first step is to rewrite this so it's no longer a number sentence. So we're going to write 682 divided by 0.32. So our step 1 is done. Next, we need to make our divisor into a whole number by multiplying both the divisor and the dividend. In other words, we're going to be moving the decimal point. So, for the divisor, we have to move it 1, 2. So we need to be fair. When we're doing our division, we need to make sure we're fair to both the divisor and the dividend. So on our, So if on our problem, 682, the decimal would have started there. So we need to move it 2 places so that we're fair to both the divisor and the dividend. So we're going to move it 1, 2, and that's a new place for our decimal. Because we moved it over, we're going to need to annex 2 zeros. And there we go. Now we have a whole number as our divisor, and we've modified both the divisor and the dividend. And so now we want to make sure that we don't forget, we're going to move the decimal straight up right now so we know where it's going to go in our answer. So our new location for our decimal is right there. We're going to move it up. So in our answer, it'll be right there. Now, this is kind of messy and hard to follow, so we're going to rewrite this as just the 32 and 6, 8, 2, 0, 0. And again, we'll add our decimal points right away. So now our new problem is 68,200 divided by 32. But remember, this is still going to keep the same quotient as our original problem did. So now we're going to start dividing it like we have before. So to get extra practice, we'll do this together. We're going to ask how many times does 32 go into 68? Think about it. Goes in 2 times without going over. So 2 times 32 gives us 64. We're going to subtract 64 from 68. We get 4. We bring down the next digit of our divisor, which is 2. We ask ourselves that question again. How many times does 32 go into 42 without going over? Our answer to that is 1. So we do 1 times 32 gives us 32. And then we're going to subtract that. 42 minus 32 gives us 10. So now we still have more digits in our divisor before we reach the decimal, even though they're zeros, but they're before the decimal, so we have to keep going. So we're going to bring down the next 0. We're going to ask ourselves, how many times can 32 go into 100? Think about that for a second. And we'll try 3. So 3 times 32 gives us 96. We'll subtract that. So just remember, we're going to take a moment, pause, and think about this. There are 2 methods we can use to solve this subtraction right now. We can use borrowing, or we can use the add up method. I would prefer to use the add up method. So for this, I'm going to think, how much more do I need to get from 96 to 100? I just need 4. So to check my work, I'll do 96 plus 4 equals 100. So I use the count up method correctly. Now I'm going to bring down one more 0. And I'll say, how many times does 32 go into 40 without going over? It goes in 1 time. 1 times 32 is 32. We're going to subtract. We get 8. We still don't have a 0 down here, so we need to annex one more 0 and bring it down. Ask ourselves, how many times does 32 go into 80? We're going to have to use 2 times. We have 64. When we subtract, we get 116. Get one more 0. 160. We're going to ask ourselves, how many times does 32 go into 160. And we will try, let's go with 6 and see if we get an answer that works without going over. So 6 times 2 is 12, carry the 1. 6 times 3 is 18. So see, I made a mistake. That's too much. So we'll try one that's lower. We'll try 5. 5 times 2 is 10. Carry the 1. 5 times 3 is 15 plus 1 is 16. So we're going to subtract. We get 0 down here. So we have a 0 here. And there are no more numbers for us to bring down up here. So because we have both those situations, we know that we're done. So we check our decimal point. We brought it up. So that's going to be our answer. Our answer to our problem is 2,131.25. So that is our final answer. Now, I want you to try this using the same process. So I'm going to give you time to pause the video and do this by yourself before we go over it. Okay, so first we're going to rewrite this so it is no longer a number sentence. Now we're going to look at our division problem, ask ourselves, is the divisor a whole number? In this case, it is not. So we're going to move our decimal point 2 times to make it a whole number, but I have to do it to the dividend as well. So I'm going to take the decimal point and move it 1, 2, and here's where our new location for our decimal point is in our dividend. So before we forget, let's move the decimal straight up so we know where it goes in our answer. So we've got these 2 steps done. Now we're going to rewrite it one more time, so it's a little bit cleaner. We can see that we can see more easily that our divisor is a whole number. So 45, 103.50. Let's put our decimal points in there right away. And now we're ready to divide because we see that our divisor is a whole number and we have our decimal point in the right spot. So we're going to start off asking, can 45 go into 10 without going over any number of times? No. So now we're going to look at 103. Can 45 go into 103 without going over? Yes. We're going to ask ourselves how many times can go in twice without going over. So we're going to do 2 times 45 gives us 90. When we subtract, again, we can use a count out method if we choose. We get 13. We have another digit in our divisor, so we'll bring down the 5. And we'll ask ourselves, how many times can 45 go into 135 without going over? 3. So we do 3 times 45 gives us 135. We subtract and we get 0, but there is still one more number to bring down in our dividend. So I'll bring that down. And we'll ask ourselves, how many times can 45 go into 0? 0. 0 minus 0 is 0. Now, we get 0 down here, and we have no more digits in our dividend to bring down as well. So because we have both of those conditions, we know that we're done with our long division, and now we just double check our decimal point. We brought it straight up, so we're good to go. So our final answer for this problem is 230. If you didn't get that right, try it again by yourself and then check your work one more time. Here is some extra practice for you to do individually as well. Double check your answer with a calculator, use compatible numbers to estimate, and then see if you can get the right answer. If you have any questions on this, just let us know when you come to class and we'll answer it for you and look at your work. And that's the end of our presentation.